this video I show how I cut two parallel depth bevel gears. It took me a while to understand the machining sequence from what is floating on the internet. This is a clearer explanation. The pitch cone angle for these gears is 45 degrees and they meet at 90 degrees. The compound is consequently angled at 45 degrees to cut the gear blank. For the same reason, the dividing head is also set at 45 degrees. The dividing head I built is meant to be held in the mill vise. However, in this setup, it is held by a screw through the base which engages a round bar securely held in the jaw groove. These are the formulas for calculating the blank dimensions. The blank is turned till the required diameter at the small end is reached. This shall be a 12-tooth gear. The equivalent cutter for a bevel gear would not cut a correct profile. The correct cutter to be used is obtained using this formula. In this case the cutter to be used is that for a 17-tooth gear. To align the cutter with the blank center, the cutter is brought in contact with the top of the blank. It is then lowered by a distance equivalent to half the cutter's width plus the blank radius. A ruler is used to double-check. The cutter is brought into contact with the face of the gear blank. It is then fed in 2.25 mm, the depth of cut for a Mod 1 cutter. The first cut needs to be marked for future reference. The dividing head has a 60-tooth gear. To cut 12 teeth, I need to crank the handle 5 times per tooth on any plate. It is important to select a plate that is divisible by 4. Also, it is important to note the amount of backlash on the selected plate as you'll need to reverse rotation. In this case I selected a 16-hole plate and the backlash is 1 hole. All the teeth are cut. The gear profile is only correct at the small end. Gears would mesh correctly here. However, they would foul at the large end. The teeth need to be corrected. This is the complete sequence of machining. The first stage has been completed, the rest are the required corrections. For the first correction, the cutter is raised by the indicated amount. The chuck is rotated clockwise by a quarter of the index angle. One full turn. And 4 holes on the 16-hole plate. The gear is indexed from this position, to touch up one side of each tooth. Once all the teeth had a go, the other side of each tooth is machined. For clarity's sake, the cutter and the chuck are first returned to the original setup. From the centered position, the cutter is lowered by the indicated amount. The chuck is rotated anti-clockwise to the start position. The amount of backlash needs to be determined beforehand. It was seen to be 1 hole in the 16-hole plate. Rotate by 1 full turn. And 4 holes. That's the start position. And 1 hole for the gods of backlash. We are at the start position, corrected for backlash. Then the chuck is rotated anti-clockwise by 1/4 of the index angle. That's 1 turn and 4 holes. The gear is indexed from this position, to touch up the side opposite to that previously machined. As per the first setup, 5 turns are required per tooth. And the gear gets another go around. And it's done. Looks like a bevel gear to me. With this setup I can adjust the meshing of the gears. They seem to run okay. And there is barely any discernible play. Some oil to run them under power. Noisy. But that's why helical bevel gears were invented. And a bit in the opposite direction. I see no bent teeth, nor signs of excessive wear. Got it right on my first try.